Okay, so who here has basically said this before, which is works on my machine? Okay, right. So this is just going to be a collection of tips to avoid that. Let's try and minimize how many times we say that, right? This is not going to be a huge amount of complex Python. This is just going to be little tips to avoid situations where you say, works on my machine. I don't know why it's not running in production. Okay, so how do we normally set things up, right? So a lot of times we have things where we've manually typed stuff, we haven't automated it, somebody's running Linux, somebody's running Windows, somebody's running OS 10, and what happens? So you hand this over to your colleague and they're like, मेरी machine पे चल नहीं रहा. Okay, well, what do? And so basically most times you gently build something that looks kind of like this, and then eventually somebody touches something and that's what happens, right? Now, why does this happen? I mean, this happens because what most people don't realize is that the top part of that iceberg, that's the code you've typed in. If you're using libraries, if you're setting your system up with other things in it, most of this is actually sitting below the water. So, you need to do a bunch of different things. And so these are some of the reasons. I'm not really necessarily going to read it out because everybody here can read. So, you have a variety of reasons why this happens. So I'm going to try and figure out how to avoid the situation. So a few things: isolation, repeatability, consistency, testing, and observability. I'm going to demo a few things. I'm not going to demo all of these things because that would be hugely out of scope, but initial environments. So you have things like, your system packages, which could be how Python is installed itself. Then you have things like, what libraries you're using, things like potentially if you have C modules, things like that. You have build dependencies. Then if you have C modules, then you need header files. And if you have all of that, then you need a compiler. So then you have a situation where you have to do global installs. So what I'm going to do is I'm going to do a quick demo of what happens when you end up with having to do global installs. So I'm going to basically mirror now. Okay. Right, so this is a little VM. So I want to install a Python package, right? Let's see. What do I do? So, what happened? Oh my God, there's no pip. Okay, well, what do I do? So how do I figure this out? Oh no pip3. So now I have to figure out how to install that. Yeah. So this is all, all sorts of crazy stuff going on. Now I need to figure out how do I want to install requests, right? So do I use my package manager on my system? What do I do? So what I'm going to do is I'm going to install Okay, this is how much stuff I need to install. 247 megabytes worth of stuff. I'm not going to do it because we have better things to do, but this is not great, right? It's not a great situation to be in. So what you've done is to figure out where you should stop where you should start using simple package management, consistent package management. What happens if you now need to do this on somebody's Mac? There's no aptitude, you're not on Ubuntu anymore, things look different. So what you're going to have to do is, I'm going to turn mirroring off. I'm going to do this a few times, so please bear with me. So what you're going to have to do is, I'm going to first need to figure out where my presentation screen is. Never mind. So what you're going to need to do is, you need to go and run, it's playing, okay, cool. Right, so what you end up with is you have a little snowflake on your machine, right? So you need to figure out how you install pip still. So you Google it, and you come to this, right? So now your package manager has pip, and Python has pip, and you don't know what to do, so you go to the guidance. And it says, oh, pip is already installed, but pip is not installed, so, and then they say, okay, well, there's this nice thing in red on the Python website of that URL that says, be cautious, which is not a great thing when you're starting Python development. You don't really want to have to worry about things like, how to be cautious. Anyway, you've installed pip. I recommend you do it via your package manager, or you just install a Python distribution. And now you need to update the request library. So what do you do? So what you're going to have to do is you have to go. There displays. Okay. You're going to have to basically figure out how to find requests, right? So we have Python 3, sorry. We have Python 3, and we shouldn't have requests because we haven't installed it yet. So let's see, import. Oh my God, we do have requests. What do we do? Magically have it, but you shouldn't have it. And then if you need a new version request, how do you update it? So there's all sorts of questions going on. And the trick is you want isolation, right? So you want to actually have a new version of your libraries, and let's see, figure out where this is. Okay, cool. So what you need to do is you've got a fragile system, and what happens? You have no idea what to do. You're confused, you're lost, you're bewildered, you're disoriented, and your package manager is the dog. You're effectively, the person pulling it is pip. So you have no idea how to manage these. So you do a little bit of research and you figure out what are you supposed to use. So then you decide, I want to use virtualenv. Okay, so you decide you're going to use virtualenv. Who here knows about virtualenv? Okay, good. At the very least, use virtualenv. It's now included in modern versions of Python. Make sure that that you use it. It isolates things into their own packages, and effectively, it's quite straightforward for you to install things using virtualenv. So we'll do a quick demo of this, right? So let's see. You've got, what you can do is you can put all your dependencies in requirements file. One moment. Yeah, I'll just mirror. Okay, so can everybody see this? Or do you need bigger? Sabko nazar aa raha hai ya bada karu? Okay, good. Everybody can see. Excellent. So we've put one thing in the requirements file, put arrow in there, and you can simply just, do this, which is you can do a pip install. So basically, you can simply make a virtualenv, which is okay. So what I'm going to do is got a nice little virtualenv. I have a directory here called testenv. I can activate it, and now effectively I have my own nice little Python. So now let's see which libraries I have, right? So I have pip here. I can do मैंने आपको library बताई थी, requirements file है. It's got arrow in it. I've got, amazingly, I have pip. Yes, amazing. I can just do -r. I can install my requirements. Cool. Hey, look. So, and let's see now if I make a new shell and I blow it up a few hundred times, and I try and do, so the arrow library I've just installed, right? New Python, import. Okay. No arrow, amazing. So I don't have to worry about the arrow library being installed all over the place. It's only available in this project. And it's not messing with anything else on my machine. So please, please use virtualenv. So basically, my talk. So you have all of your packages are isolated. You can use them quite simply. That's quite a win. So effectively, this is, I always try and put a little Monty Python image. So this is, Python is not named after a snake. It's actually named after a bunch of comedians. These are the bunch of comedians, and effectively what you have is you now have, a nice little cage for your environment. So this might be a contrived joke, but it's an attempt. But this is still not good enough. Who here has done any work in something like Node.js? Who here has used NPM? Yeah, works nicely, doesn't it? Everything is nice and isolated. So for Ruby, you have bundler. For Node.js, you have NPM. For Rust, you have cargo. Rust is slightly different, but you have real dependency management. So you put stuff in a requirements text file. You just put a name. Transitive dependencies are all over the place. You have no idea what's been installed where. Python now has two options. There's a project called pipenv by Kenneth Reitz and a project called Poetry by Sebastian Eustace. Who is using pipenv? Amazing. 2 people? Okay, please use pipenv because you get deterministic builds. Works on my machine, does not happen. That happens much, much less with pipenv. So let's do a quick demo of what pipenv looks like. So what I've done is you can basically take a pipenv file. You can do pipenv. You can do a quick pipenv install help, and you can basically give it a requirements file, right? So I have so all I did was I run this in advance because I don't want to have to waste time downloading all of this stuff. It's creating 2 things, a pip file and a pip file.lock. So let's get the pip file, right? Or let's take a quick look at it. Frozen, the Python version that you require, it's basically said you need a version of arrow. Now, this is similarly requirements.txt file. It says I need a version of arrow, but there's a trick, right? You've got a lock file, and effectively that contains hashes of everything. It actually contains all of the dependencies that arrow has, and so it very, very nicely gives you a deterministic build. So it'll install the same versions every time because you've locked them, just like NPM or newer versions of NPM. So please use real dependency management instead of just sticking stuff into the requirements file. Similarly, Poetry is a bit ahead of the game there. So in Poetry's case, if you take a look, you've got a nice little project structure, and all you need to do is you need to go here, you need to go out, you can just do Poetry, create, Poetry, new, and effectively I've just created a new project. If you can see my screen, it says I can create a new thing called coverage demo. So I can create a new project, and it creates a whole structure for me. So let's do a new one, right? So in the great tradition of demos, foobar, right? So I have tree of foobar. I have a nice setup where I've got a README file, and all of that is set up for me, just like NPM. So we're still playing catch up in the Python world, but we now have better tooling. So I've got a pre-prepared one, and so I'm going to go here to my Poetry one. And again, with Poetry, I took the same thing that was arrow, and I've added the same dependency to it. So now instead of a project file, or instead of a pipenv file, it just creates a PyProject toml file. This is now a spec. So PEP 518 is actually, there's an enhancement project. It's been accepted. It's a spec. And from now, build systems will all be defined in toml files. So if you're using new projects, please use Poetry. If you're migrating, use pipenv instead. Poetry is a bit nicer. The dependency solver is a bit nicer. Anyone here use Poetry already? Okay. It's fun. Check it out. It's handy. The URL for it is in here. The presentation should be available. If anyone wants to take a screenshot, it's quite useful. The nice thing with both of these is that you can very easily install, run this against any multiple versions of Python on your machine. So we went from basically having system libraries all over the place to having isolated environments. So my demos are done, and victory, right? When we actually won a World Cup. So if you actually want to use, from here on, you actually now want to use multiple versions of Python. Who here is stuck with a project that actually still needs Python 2.7? I'm really sorry. You have 2.5 months, and after that, God be with you, because it's gone. No support left for it. But if you need it, you can use Python. Python will allow you to install multiple Python versions on your machine, and there's a really nice way to then mandate what you have. So you've installed Python. I'm not going to tell you how to install it. That would be a workshop. What it helps you avoid is, oh, I don't have Python 2.7. Oh, I need to install Python 3.7.1. So what it uses is a nice little thing so if I show you the structure of this demo, which is 2.7.14, it contains one file, right? Well, it should contain one file. It doesn't, right? So all it needs is one file called Python demo 3.7.1. It should contain a .python version file. When I show you that file, it contains something very simple. When you change into here, let's take a look at which Python version I'm using now. Python 3.7.1. Now, if I get out of this directory, which version of Python am I using now? Python 3.7.4. So if you use Python, you can basically check this into your repo. You can check the version you need, and it'll always run with that version. Again, so the works on my machine situation is avoided. Back to regularly scheduled programming. So there's another version if you want. If you don't like Python for some reason, ASDF, if you use multiple languages, ASDF has plugins for multiple languages, and you can manage language versions that way, including the JVM. So if you're in the unfortunate situation where you're still using Java, please use ASDF, and you'll be somewhat happier. So this is effectively managing varmints. I spent a lot of time on that because that's usually the most painful thing, right? But what do you do with, when you're dealing with code? You've got your little project, and you've decided that you want to do things a certain way, and then somebody else joins, and then they look at your code and they're like, oh God, what has this person done? And I'm going to borrow from giants. So Abelson and Sussman, who wrote structure interpretation of computer programs, very famous computer science professors, they wrote, programs must be written for people to read and only incidentally for machines to execute. Because machines don't care about syntax and formatting and all that. As long as sort of the code compiles, it's happy. But you're going to have to maintain it. So let's come up with a consistent style. Luckily, Python has a consistent style guide. Who here knows about PEP 8? Okay, PEP 8 is good. Who here remembers all of PEP 8 when they're writing code? Yeah? Okay. Do you use double quotes or single quotes? Why? Does PEP 8 say you have to use them?
You can use anyone.
Exactly. it's inconsistent, right? So why are you doing this? Who here's done any GoLine? Okay, so GoLine did something really, really nice. They basically said, you can basically write your code any way you like, as long as basically it compiles, or we'll basically format it for you. So they use tabs for indentation. If you don't like it, that's fine, but that's what they use. They wrote a tool. Machines are much better at formatting things than you are. Just leave it to a machine. So in Python, we have tools similarly, right? So we have a nice little tool called Black, which I'll demo for you, right? Can you see? Okay, right. So effectively, I've got initial code here. Right, and this code is very, very sad. So let's take a quick look at this. Okay, should we write code this way? Right, so is this fun to reformat? It's fun to reformat. You like reformatting code this way? So what we'll do is, we're just going to magically reformat this, right? So what we'll do is, what we'll quickly do here is, okay, well, this didn't work, right? So this is why I have a branch. Okay, magic, right? So all I ran was poetry run. I ran poetry run black. It reformatted my code. I didn't have to do a thing. So machines can do this better than you in most cases. Don't worry about it. Don't waste your time. Everyone's code will look the same way. Double quotes and single quotes, no longer a problem, right? So similarly, just formatting is okay, but you probably want to do something a little bit more, right? So we've dealt with formatting. What about good practice? So this is effectively about making sure you use good tooling again. It's there for you, so it's going to point out what I'm doing wrong. Let's run. Fun. Okay. Poetry. I think this is, yeah, right. Okay, I know what happened, right. So effectively, you can run pylint against this. Okay, yeah, great. look at that. I now have a rating. So it's got numbers against my code, and it's telling me exactly what I need to do. So similar to things like JSLint and stuff like that, but again, machines can tell you how to make your code better. Use the machine. This is not fun to have to do manually. Right. Okay, who here has used MyPy, and why should we use MyPy? Who's used type hints in Python 4.8.4? Okay. Python's dynamically typed. I know it's kind of sacrilegious to basically, say you should have static type hints, but this makes life nice. It makes life actually pretty easy. They are not enforced at runtime, and they will catch a class of errors that you will not otherwise see. So here's a little bit of a demo for let's see. I renumbered these and forgot a limitation. I'll tell people after this in the lounge what my mess up was, but I have to make things untidy again, right? So I've got broken types in here, right? This code will run. So let's do this. Poetry run Python MyPy. So it's just cat. So can people see this? It's fairly straightforward. Do you want me to turn syntax highlighting on? Okay, right. So what I've done is I've done something pretty silly, right? So I basically said this is a method that will this is a function that's going to take 2 strings and return an int. This doesn't make any sense. It's going to take 2 strings and return a string. If I run this, as you saw when I ran it, it just worked. However, if I do this, right? And if I do this, it'll run. If I actually do what I intended to, which is, look at that. I've got errors now. These would never actually have been caught at runtime even because, and your functions would have been incorrect. So I recommend, again, MyPy is nice. Consider using it. You don't have to use all of these tools at once, but these are just nice little tools you can have in your arsenal. Let's correct these errors now, right? So okay, look at that. So we've got a function called combine strings. It takes 2 strings. When it adds them, it returns a type of string. And you've effectively got something that's calling them. So it's telling you what's going on. So now let's run MyPy again, yeah? No errors. So right, so I have a code that's partially covered. I've got some tests written, so let's just do this. So let's open up. I've got something that's writing that's a really, really simple function. It's effectively calling a map, just basically it's got a conditional. This is typed, by the way. It's typed, it's hinted. And so I'm going to open right. I have a really simple test. Nothing is tested in it, right? So let's see what we get. We've got another test in here, which is right. So now let's run coverage on it, right? So what I'm using is a little something here, and this is not right. So this is all messed up, right? So, and I've got missing coverage here. So, notice that I've got 20% coverage on this. Now, let's do this. Oh, look, I've got 100%. Let's look at the change that I made in my tests, right? So, so I've effectively, here's my test, and let's do this. I've got here, and I've got my function. This has a conditional. It's not tested. The second one was, condition wasn't tested. When I added it, now I've got test coverage. Things are happy, I have 100% coverage. Things with test coverage is, don't be obsessed with 100% test coverage. Most times it's going to be a waste of time. Basically, get to covering all your code. The nice thing about test coverage is it tells you what you haven't covered, tells you what you should consider covering. Don't play the coverage number game because it'll just be a waste of your time. In most cases, 80% or something is good enough. Okay, now I'm going to stop doing constant demos. So you've effectively written your code, you've written tests, you've checked coverage around it. You have to deploy your code. Effectively now there's really only one game in town, right? Use Docker. Use Docker to build things. Use Docker to run tests on your CI system, or if you're running a hosted thing like Mashood talked about, make sure it's well defined. They often use Docker under the hood as well. But use it to run your tests because you can define your entire environment very, very cleanly. Use it to create your build deployable as well. You can either deploy into Docker, or if you're doing serverless or anything like that, you can very, very easily build your serverless archive that way. Quite straightforward. If anybody has questions about it, please ask me afterwards. But don't install all sorts of crazy things locally to try and build your project. It's always going to be painful to update. So yeah, use it for test, use it for build. What Docker does, and I think Mashood had a good explanation of it as well, but this is a little bit further. So what Docker does is, let's see, do we have a pointer here? No. Okay. So what you have is, the first layer is the base layer. Then anything you add on top of it, you can just basically create all sorts of things. So over here, you could have your first layer, which is your application. And on top of that, it could be things like that are required to test it. So you could have a very, very nice way to have the stuff that you need, and any additional stuff, you don't necessarily have to make part of your deployable. It can just be a simple layer. It's very fast to build as a result. And again, you have consistent builds because those are actually checksum values. So you don't have to worry about a whole bunch of things. Okay, so now you've built your thing. Who here knows about observability? Okay, observability is basically how do you know what your application is doing without having to look at the code, right? So make sure that you use logs. Python has a standard logging library. It has formatters available in the standard in PyPI, and you should use those. Make sure you're sending your logs places, and make sure you're doing events and traces. And this is pretty much it. My talk's done. Sorry to keep you. We're running late, but make sure your code is isolated. Make sure your builds are repeatable. Make sure it's tested, and make sure things are observable. If anybody has any questions, please ask me afterwards. Thank you.